Yeah,
Yep.
great. So, hi everyone. Thanks for coming to the Dash community call. So, today is our 108th meeting, just FYI. So we've met 108 times. And what I'm showing you on the screen is a combination of notes from the last time we met. I was a little bit late because I was out of office, but this is just a recap of the things we've talked about for the new people. I do a summary at the top of things that we talked about and link everything. And for further reading, we have full meeting notes below. And that's where we have everyone who attended, the items we're working on in our project board, and of course, the ones that got done this week. Those are the fun ones because those are the ones in green. And the too long don't have to read. These are actually the longer explanations of the things that we talked about. For example, last week we did flow resimulation and flow reconciliation, and Riff explained a lot about those two PRs, and also it had some Q&A, and then also the bulk sync support API. And then we have follow-up tasks, and we actually had behavioral model last week too. And then, sorry, I'm yawning. Here, if you've missed the meeting or what was said, then here are the links to either the YouTube video or the Teams video. So if you are not receiving the notes, please put something in the chat window if you'd like to receive them, and I can add you to the list. So that's what happened last week. And then this week, we have Riff had an item that he wanted to talk about, and we also had a couple of PRs in the queue here. So Riff, did you want to go first, or would you guys want to talk about the PRs that you have? Oh, hi, Clark. I didn't see you there.
Hey, hello. Hi, Kristen.
Hi, how you doing?
Yeah, good. And I
Good. Good.
bring a new colleague joining this
Oh,
meeting. He's
oh,
working
great.
on the control plane, so uh, he may be much more interested in this
Uh-huh.
uh, Wraith proposal.
Uh-huh. Great.
Yeah.
So is that Yafeng?
Yes, Yanfeng.
Okay.
Yes.
Hi,
Yeah.
Yafeng. Well, thanks for coming. That's awesome. So appreciate you coming. Riff, did you want to go ahead and get started on your item?
Yeah, I think my item is not like too much because we have go through the like the boxing KPIs flow reconcile. So the only thing that I have like in the list is actually just update the P4 to actually generate the flow simulation API. So there's nothing
Mm-hmm.
nothing much. Yeah,
Mm-hmm.
I would I need to we need to go through for my
Mm-hmm.
items. So I will leave most of the time for like Zhixiong clock and info.
Okay.
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 Yep.
Yeah, let's go forward with that then. So do you guys want
Thank you,
to
Christina.
share? Yeah, thanks. Did you guys want to share the screen yourself, or do you want me to present for you?
Hi. I think I can present by myself. So I'm
Okay, I will
sharing my
stop the
screen.
share. Okay,
Yeah, I'm sharing
great,
myself now.
great, thank you.
Uh,
And I don't see your screen. Oh, here it comes. And maybe if you could, because more people joined, you could just introduce yourselves one more time, just briefly for the team.
Sure. Hello,
Thanks.
everyone. This is Zhixiong from Microsoft Research Asia. Actually, I'm located in Beijing, and we also have some Alibaba partners to co-propose the Dash Flow API. So uh, maybe uh, we can I can present it now, and we can
Yeah.
discuss. If you have some comments, feel free to interrupt us. Yeah.
Okay,
So
so Q&A during the presentation. Got it.
yeah. It doesn't matter. Yeah, we
Okay,
can start. Yeah.
thank you very
Firstly,
much.
this is the outline. Sorry, I just moved it here.
Mhm.
Outline of the my presentation. Firstly, actually, it's a small introduction on the Dash and the Dash Flow API to give you some background, and then we have 3 use cases, and and then we will introduce the Dash Flow design and some how to implement the design, how to implement the use cases with the Dashflow API. Yeah.
Mhm.
let's get started. The first one, that is the introduction. Actually, I think this is a Dash community meeting, so I think everybody knows the background of Dash. So we want to actually, Dashflow API want to further enhance Dashflow processing capability, and we provide a Dashflow abstraction layer to facilitate the vendor neutral flow management. For example, you can see the figure. We have actually for Dash, we have fast pass and the slow pass. And if actually we will build in the Dash flow abstraction in the connection track lookup. And when it is hit, actually we can use the flow states and use all of the flow states and to make it go to the metering update directly. Otherwise, if that is a flow miss, it all go to the normal period, use a slow pass to go to the echo routing and so on, and then add it into the added the flow into the flow table, and then for the next time it can go to the fast pass without using the flow pass to further improve the speed of flow processing. So, and then I think I can, Clark and Feng from Alibaba can give some use cases on their NAT gateway and to show why we need the Flow API. So maybe let's welcome Clark and Feng to introduce. Yeah.
Okay, thank you. Yeah, this picture. Okay, yeah. This is the one of the deployment. Actually, the first deployment of a Dash-based system in our edge cloud deployment as the gateway. This page, actually, we can see it. The SNA2 is our devices built as a smart switch running DPU and a switch on it. And then we can see the deployment scenario. The users, for example, for the yellow guy is the card game user. It accessed from the internet to the gateway that located in the internet service providers data center server room, and then it go through the gateway and access the server deploy also in the ISP's server room with overlay network. So the gateway works as actually we can see it as a stateless DNet or load balancer to deliver the traffic to the servers. Another use case is that the online shopper assess the content may be located in the central cloud storage and some kind of services, and the server through the gateway to using the VXLAN network to going through the gateway to decap the VXLAN packet and then send the normal IPv4 or IPv6 packet to the central cloud to fetch the data and get the or invoke some RPC calls in this processing. So the SNA2 actually is working as the load balancer. This is one of the gateway, one of our use case, and the processing and the transformation of the data of the packet in encap, decap, and replace the source IP, des IP, and things like this is done in the DPU. Zhixiong, please, next. Okay, this is another use case. It's SNet. Alibaba Cloud is providing some kind of cloud services for example, the storage or some positioning service and some AI recommendation services running in the central cloud. And local user may access some service for the gaming is assessing this. For example, to launching the initial game, it may fetch the data from the storage and get some positioning service to locate the users, and then it also goes through the net translation, because all the services running in the green server is running in a VXLAN network, and then it get public IP to access the services away from the cloud. And the right side is located as the edge, and the left side is the central cloud services. Yeah, and both of these use cases is built within the smart switch, which is we think we can move the control plane to the dash, but it is scheduled. We have 2 steps. The first step may be because we may deliver this summer, I think it's June. So the first step we are not using dash, but the second step we may move both the control plane and data plane entry population with dash. Maybe Yanfeng may follow this item in our deployment. I think this is the use case in Alibaba. Zhixiong.
Thank you. And and after we introduce the design of Dash Flow API, maybe we can re-invite Clark and Feng to introduce how to use Dash Flow API to implement the scenario. So for the next, I will further introduce some use cases in Microsoft. For example, for the smart switch, I think the high availability. Actually, the goal of the smart switch high availability is to make if a single switch or DPU goes down or a network failure happens, it will not cause the existing flow to be dropped. So we need some flow level sync to get the flow entries from the active DPU and create or update the entries to the standby DPU. You can see the figure. We have kind of HA pairs, and we have the flow sync from the active to the standby. Another use case is the flow diagnosis. For example, if we found the VMA to VMB is not working, or maybe the flow cannot go through that or dropped. So we need to use some diagnosis method to get the simple flow entries from A to B, and check if the entries, check the flow entries to see what is the actual flow key and the actual flow states, and to debug and to know what happens. Maybe the output should be output maybe exists in the can be dumped into console or some gRPC or some other ways. So this is the figure. We can use Dash to get the flow entries from the flow table and then dump it to console or another way. So after we discussed the 3 use cases, 1 from Alibaba, 2 from Microsoft, actually we want to provide a Dash Flow design here, and this is already PR in the Dash repo, and everybody can give comments on the on that PR. So first, so I think today I just want to summary all of the things and give you a presentation to know why we design like this. Just I think the goal is we want to support the storage and the processing of millions of flow states, and also enhance the dash flow processing capabilities through a vendor-neutral management layer. So everybody, for different use cases, we can use the dash flow API. There is no need to reinvent or redo some works on the flow. Just use the uniform API. So the key feature, of course, is we can offer a unified control dash flow interface across the dash devices and provide abstraction of the flow table and the flow entries. Also includes the we want to include the APIs for comprehensive flow management, for example, the creation, removal, retrieval, and the configuration. The benefits that is we can enhance the control and the flexibility in managing flows in Dash, and we can have ability to develop the services for diverse scenarios. For example, we have 4 categories in, for example, some data plane applications, cloud gateway, load balancers, and for some flow management applications, flow offloading, updating, redirection, even further, even flow simulation, resimulation, and also the flow diagnosis to debug the different, to see the behavior of the actual flow states, and some foundational flow services. For example, the high availability in the smart switch, some HA things. If we want to visit all of the applications or scenarios, want to visit the flow, then we can use the dash flow API, just like the figure shows. Here is the abstraction of the dash flow. In the right hand side figure, you can see the flow entry. Actually, we have flow key and the flow states, and we can manage it. We can for each ENI, it can has different flow entries, and for a flow table, it can have the different flow entries for different ENIs. And for the flow table abstraction, we support create, remove, get, and set. And for the flow entry, we even provide a bulk get session with filters. Then we can retrieve because we have a lot of flow running on the DPU or on the different dash devices. We can use the bulk get session to get it easily. Firstly, for the flow table, actually, we defined it as a dash objects, and it supports different kind of keys. It's just like right-hand side figure. Is we have defined the enabled key map for this. If you want to, this table support different kind of keys, or all of this or any of this, you can use the enabled key map. And we also design attribute for the time to live flow in to define how the time to be aged of the table. I think this is 3 main attributes of the flow table. And for the flow entry, we have different keys. As we said, we can support the ENI flow table, and also the 5 tuples for the flow, as we said. So this can be keys. And for the attributes, we support different categories of the attributes. For example, in the metadata, we have the version, because this is for comparing different. If we have different set, different flow entries for one version, for one flow entry. Actually, you can compare their version to see which is newer. And we also support the direction and also the flow action of the of the flow entry and support the metering class. And also we can specify if this is a unidirection flow or a direction or this is a bidirection flow. By default, actually, it's a bidirection, but for some cases, it can be unidirection. And we also support put some attributes the reverse flow because most flow are bidirection, bidirectional flow entries. So we also give some reverse flow metadata to help the user to get its reverse flow by the key and value by some keys. We just save it here for a fast index of the reverse flow. And also we support the flow in cap attributes. And for some cases, maybe we need some scenarios need 2 layers of the underlay. So we provide the underlay 0 and underlay 1 to describe how does flow to be encapsulated. And the next one is the flow overlay rewrite. For some to describe, we have the MAC, SIP deep, and the SIP and diff mask to describe if a flow need to be rewritten. By the way, we also provide some extra metadata for our flow entry. For example, we have the vendor metadata to show, okay, if this flow for different vendors, they can save some metadata here. And also some protobuf data for the flow. User can use this attribute to define a flow easily and simply without give a lot of different attributes. But I think I will introduce later for the protobuf. Next, we also want to, because for a flow we have millions of flow on the dash devices, and they are always changing when it is running in production. So our goal is to firstly to get and set them, and also allow dash provider to optimize the flow sync process based on their own architecture. So we have 2 ways to receive the flow entries. The first one, that is the gRPC target server mode, and the user can set up a gRPC to receive the flows from the box session. And also we support the event notification. User can decide when to fetch the flows. And we also provide the filters, up to 5 filters to kind of get the to filter the flow box session to get the flows we need. This is the attributes of the box session. We can specify the table to get and the mode, gRPC or event, and limitation. For example, if we for diagnosis, maybe we only need 10 flows. So this we can specify limitation of the returned flows. And if that is gRPC, we have gRPC IP and port, and we support up to 5 filters for the flow. The filters actually is defined as also defined as set object. This object have the flow key, flow operation, and the value. The value can be supported, can have the int value, IP address, or MAC. For example, if we want to use some perfect sync algorithm, we need to compare the flow version to make sure the latest version should be stored in the DPU, and so So then we need to have a filter that maybe the version we need the flows, all of the flows with version less than 5, for example, and also the diagnosis. We need to get 10 flows from VMA to VMB's SSL port. So from this attributes, we can achieve this. We actually, for the filter, we iterated for many times, but actually the site have some, uh, the site have very strict requirement on this. So to make the compiling and work, so finally we found this is maybe this is the only way, or this is the simplest way to achieve this. And this is the flow filter key. You can maybe get the maybe for the version and to make it as less than and give a number of the and the version to make it as a filter object and put it into the box session. Then finally we can get what we need. If that is the gRPC target server mode, we use the this protobuf format to define that. This is actually aligned with the attributes we defined previously. And for gRPC, it's maybe because we have some serialization and deserialization, the transmission will be kind of more efficient. And for the notification, because we have two modes, the two modes are slightly different. For the gRPC target server mode, we only need to notify the box session get finished. This round is done. So when the server receives this, it can maybe can trigger next round or to check the gRPC directly. If that is the flow event notification mode, that means the user need to get new flow by themselves. So we need to notify there's a new flow and or all the flow this round is done. So these are two modes of the bulk flow bulk get session. And also we support the protobuf programming. As I said previously, we have attribute defined as a side flow entry flow data protobuf attributes. And the user can get the flow states from this directly and use the previous protobuf method format. I think the main difference between the attributes driven and the protobuf driven, that is, the attribute actually can be incremental set and get. You can get one attribute from the or set get and set one of the attribution of a flow entry. Is more flexible. But for the protobuf, when you want to increase create a flow or get a flow, even use the box session, you can only do as a complete set and get. It's more efficient, but not very flexible as the attributes driven flow get and set. User can decide what they need and to choose different kind of the flow programming. And also we defined the capability of the dash flow API. For example, we can have the total table flow count to describe the maximum number of tables can be created, and also the maximum flow entries. Even we support the capability for user to check, because the DPU, maybe the implementation from the vendor are different. So we also can indicate what flow key mask can be used in the in this device, and also if it support unidirectional flow entry, if it support bulk get session or flow create, remove, get and set, and maybe the implementation of device can have different choices of this capability, and we can get it and to implement a different scenario. Yeah, I think this is all of the design of the flow design or dash flow design. So maybe let's go back to the use cases and how how we use the flow API. Maybe let's reinvite Clark and Feng to introduce for the NAT gateway, how do they use the flow API in their scenario?
Okay. Okay, thank you, Zhixiong. Okay, I will briefly go through the usage of the Flow API in our in the net gateway use case. First one is the most direct one is the flow learning. The DPU data plane receives the packet, and upon the flow table lookup miss, and we trap it to the ARM CPU, and then the ARM CPU, based on the our data plane application, will find the resources it require and create a flow installed into the DPU with the Flow API. This is the first things, and then another one is that our HA is per device. That means we always have the pairing device as a backup gateway. So we send the meta of the flow to the DPU2 so that we can sync the flow to the backup device using also the DPU2 ARM CPU may program the flow entry in the DPU. For flow aging, the bulk API is used. We have our aging thread running with filters, which will bulk get the flows that is aged, and then we use the delete flow APIs to release those resources and free up some kind of software resources like source port. And then we also send out the aging message for the backup DPU to delete the flow, and the backup DPU ARM CPU will delete the flow also using the Flow API. In the scenario of recovery, for example, one gateway goes from down and back to up, and then we will use the bulk get API to get the flow and sync the meta to the another to the put up again device, and then use the create API to install the flows into the newly put device. And so the the DPU2 recover process is also similar to this one. Yeah, this is pretty much how we use this API to maintain, to manage the flow.
Thank you, Clark. And then I will introduce the flow diagnosis. For example, as we said, the maybe from A to VMB port SSL have some problem. So we want to find the real, the actual keys and flow states inside the dash device, and maybe dash just output into the console. So we will use the dash flow API to find maybe this maybe the VMA is 001, VMB is 02, and the 443 as a port. We want to get all of this. We just use the flow API to do the bulk get and dump it into the console. So then we can find, okay, the actual value is rejected. So we we can know the reason why it happens. And also for the flow level HA in the smart switch, we can also use the flow API. For example, if this is a new flow, we can find, okay, this is new flow arrived and forward to ARM. And the ARM, it can compute the state from the slow path and create a new flow entry via the flow-flow API and receive the flow and send it to the DPU2. And DPU2 can do the same thing and then make it back to the DPU1. And when the next packet from the same flow, we can because this is not a new flow. We can use fast pass directly. So via flow API, we can create the flow for this. And if that is a bulk transfer case, we of course it's already have the pair between the DPU1 and DPU2. DPU1 is the active, and we in the control plane we initial the bulk transfer. For example, if we use the perfect sync algorithm, we want to get all of the version flow, all of the version less than 5 flows. We can use the bulk get session API, maybe gRPC mode, and the target is DPU2, and the DPU2 can receive that from the ARM and insert via the Dashflow API. And finally, we can finish the bulk transfer by bulk transferring all of the flows we need. So there's, I think this is all of the slides we want to present. And I think this is the summary this is a standard dash flow to support million of flow states. It is a vendor neutral, and we can support different scenarios. For each scenario, they can use the dash flow API directly without modifying or without crafting their own code for the flow. And the design is flexible. We support uni or bidirectional flow, different key max of the flow. All of the CDN pack transformation currently defined in Dash. And we also support the bulk get session with 2 modes, event gRPC with up to 5 filters. And the last one is the portal buff flow programming for efficient insertion and deletion. Yeah, thank you. This is all from us.
Thank you for the presentation. That's a lot of content to ingest. I guess I would ask if anyone has questions at this point, or did you want to come back and do Q&A at some point? Team, are there any questions for the MSR and Alibaba teams?
Yeah, Mircea here. For the HA, are the DPUs 1 and 2 talking with each other, or is there an SDN controller which does a get on one and then does a bulk set on the other to sync the flows?
Sorry, you mean the flow HA, right?
Yeah, it's DPU1 talks directly with DPU2, or there is like a SDN controller that does a bulk get operation on DPU1 and then does a bulk set operation on DPU2 to sync the flows.
Oh, in my mind, actually, this is the use case, but it's decided by the actual smart switch or DPU. I mean, the user can define what they want to do with the Dashflow API. But I think for this scenario, that is the DPUA can talk with DPU2 directly. Yeah.
Yeah. Mircea, I can probably answer that question.
Yeah, please.
It's very related. Yeah. So in a HA flow sync, there are two. There are actually three things: the source DPU, desk DPU, and there is the one in the middle, like the doing the flow sync, so it is currently called switch bus D, but we usually call it like, we also call it like flow sync D. So how it works is that on the source side, because we need to send the flow out. So by looking at the current like side APIs, so basically, the only thing we can do is that we actually go and get all the flow entries as a key, and then query the flow states in another call. But the flow can change, so this API done really well. And it also like time consuming. So what I end up with is that we can directly ask the source DPU to send the flow states or flow the flow entries to the other side. So basically, because the other side is also a gRPC, so you can be the flow sync D, or it can be on the other side, like the DPU directly. So it is the most efficient way, and it allows like any optimization that needs to be done per like vendor's implementation. So yeah, that's basically it. And to start simple, as we can see here, we can just like, okay, call the source part, and then the flow will just send to the destination part. And in the future, when like vDPU gets added, we have like multi-DPU, we need to distribute the load, then we can naturally insert the flow sync in the middle to distribute the flow without introduce any new changes. So I think that's a good thing. Yeah, does that answer the question, Mitchell?
Yes, thank you very much. And I have another one regarding the double encapsulation or double tunneling. Is there any other way to do that API so we don't use underlay 0 and underlay 1? Because when you don't have underlay 1, the actual underlay 1 will be actually the overlay. And I don't know if the API can be done better so we don't use 0 and 1 for the underlay. More like maybe tunnel, and then a tunnel can be in another tunnel or something. I don't know. I don't know if the size supports this kind of chaining tunnels or other constructs, so we don't have to create attributes with 0 and 1.
Yeah, I think that's actually a good question. So I can share some of the background on that one. The underlay 0 and underlay 1. So initially in Dash, yes, there is no so-called like underlay 1. It's just underlay. Then when the Perblink NSG gets introduced, so I believe I checked like Zhixiong's PR in the beginning, and it is only like underlay. There is no underlay 1. That's the case. So, but then after the PLNG, then we can have like 2 layers of a tunnel. So it is indeed like the chaining of tunnel, if you like to put it that way. So the underlay 0, underlay in a PLNG case, the underlay 0 will be still like the Perblink encap. The underlay 1 will actually be the NSG encap. So that is actually can find it in the PL and PLNG design doc. So we have the SDN transformation over there. That means that the flow can have like maximum 2 layers of encap, which needs to be defined here. So I left the comment here, and then you end up with like underlay 0 and underlay 1. But if you have any the better names or clear way to actually prefer, feel free to leave the comment. We can actually like iterate over it. Does that make sense?
Yes, unfortunately, I don't know size that well to be able to make a good suggestion here. This is what I was asking.
Yeah. So it is literally 2 layers of tunnels, and and depends on the scenario, because you can see the other one is basically a extra route. It can be defined in any place. It's just like a tunnel dash tunnel ID, then be put into the CAPM mapping at this moment. But you can see the routing type. We actually some of the routing type doesn't even have encap. For example, direct doesn't even have encap. So then tunnel may be put will be translated into the underlay 0 or into the underlay 1. So it really depends on the cases, and yeah, that's why.
Yeah, and I'm asking also because this tunnels doesn't necessarily need to be VXLAN. Yeah, there could be IP over IP or VXLAN and VGRE, or there could be other combinations. I see VNI, or I don't know. I think VNI is a field that looks mandatory.
Yeah. If it is NVGRE, then NVGRE still have VNI, but I don't think we have IP in IP at this moment. At least moment defined in Dash as a part of the encapsulation. Yeah, but if it is IP
heard of that.
or then there is no VNI indeed.
Any other questions, guys, for this PR and session?
I'm curious. This is Chris. I'm curious. Have you done any experiments, like with large numbers of flows, to look at the performance and behavior?
I think that's a good
Zhixiong and Zhixiong and Yanfeng.
I think this is a good question, but I think this is more on the API design. So we did some experiments on the percento SONiC, but
probably not good to talk about that. In a public meeting. But Chris, if you like this thing offline, we can probably think offline. So
sure.
We indeed did some of the experiments.
Yeah, I'm not. It's not that I want to necessarily look at the numbers and comment. It's just that a general comment would be design this complicated with this kind of performance implications. It might be good to do some proof of concept, even if you don't implement the whole thing, to find like the critical path and see what the performance is. Even if you, for example, dummied up a bunch of entries and blasted them over to the gRPC server without any computation, just how long does it take to even transfer those messages? You know, those kinds of reality check before you get too invested. That's just a recommendation.
Yeah, I think Zhixiong already did that, right, Zhixiong?
Yeah.
So there are some numbers over there, and but because yes, probably it's not really good to share with like in a public space. But if you like to chat privately, we actually did that. We can share the numbers like the experiments. And but so far
Awesome.
it is okay. It is acceptable.
So it looks like we're running up on time. I wanted to say thank you to Zhixiong and Alibaba for presenting this. And I suppose the next step is are we going to wait for some APIs or to look at in the community, or what do you feel the next steps are, guys?
I think so far, in my mind, this because this PR is open, is open as a pull request, and if any of you get interested, maybe feel free to get it, to check some details, and provide some comments, and we will make some efforts on it, and hope it can be merged soon.
So 462, guys, PR 462. Thank you so much. Go ahead, Riff. Sorry.
Yeah. Oh, sorry. Zhixiong, I think you also have a like the P4 update PR. But
yeah.
I think that is in draft mode probably still. But I think that is pretty much the implementation of.
Sure. I think I will. Yeah, I think I will put put that one in the introduction, and by visiting this one, you can check both the doc and also a link to see the P4 version.
Yeah. Although the P4 version, there is no actual complete implementation, but it should generate the API.
Yes, yes, yes.
Yeah. Okay.
Great. Thank you.
Riff, just one question, right? So yeah, I understand that the detailed design document is in the pull request, right? And I've seen it. But if you can share this presentation with us also, then it's good to look at it for a quick reference, or or show it to the rest of our team members. It's pretty concise, right? Yeah.
Yeah, if you guys are willing to
Yeah.
provide the presentation to Riff or myself, there is a slides section in the Dash repo, and I can post it there.
Yeah, Zhixiong, do you mind
Would that-
to like create a PR, upload the slide and everything?
No problem, no problem. I can do this.
Okay, I'll put
so
the
much.
link to that area then. And also
Thanks.
too, yeah, shifting gears just a little bit before we go. I noticed we have someone new on the call, Kamal Sharma. Maybe if you'd want to introduce yourself real quick, since we're a pretty tight group. Hi, Kamal. I think you're on mute. If you could come off and introduce yourself. Don Ewald, are you on the line?
I am.
Is Kamal a coworker of yours, or?
Let me see.
Yeah, Kamal looks like he's a Cisco product manager. So from what I can tell, I didn't see the alias other than his name. So this name,
Okay.
he comes from the
Great.
product management side of the Cisco.
Oh, fantastic. Thank you.
Our
So
business
welcome.
unit. Yeah, thank you.
Welcome to Kamal, and thank you everyone again for all the content today. I'll stop the recording and I'll send out the meeting notes. I'll make sure that everyone on the call is added to the correct groups, and